Heat, an explanation of heat, thermal energy, and temperature by Molly Green for NSCU 304 at Brandman University. Harry Truman once said, "If you can't stand the heat, get out of the kitchen," which is good advice even if he didn't quite mean it literally. What exactly is heat, though? To answer that, I offer a question. A grande iced latte and a grande hot latte walk into a bar. Which cup contains more heat? The uninitiated probably think this is a silly question. The cup of coffee contains more heat, right? Wrong. Neither cup contains heat. According to conceptual physical science, the literal definition of heat is the thermal energy transferred from one thing to another due to a temperature difference. Heat is energy. We do not pour ourselves a cup of energy, even if energy is our end goal when it comes to coffee. We pour the coffee, and we experience the transfer of thermal energy when we feel the hot or cold temperature. So what exactly do we mean by thermal energy? Thermal energy is the energy within a system that is responsible for its temperature. It comes from the energetic jostling of atoms and molecules within the system. Think of the movement and the resulting heat involved with generating friction. Like conversation is an exchange of words, heat is an exchange of energy. Essentially, we feel heat because the temperature of whatever is touching our body is more elevated than whatever it is touching. Perhaps the temperature of the air is higher than the temperature of our skin. Perhaps the temperature of the food on our plate is higher than the temperature of our mouth. It's all relative. What do we think of when we think of the word temperature? Depending on the day, the temperature outside can be our best friend or our worst enemy. August in Los Angeles, I'm looking at you. How many times have we said, "Be careful, that's hot," or "My coffee's cold," or "Does she feel warm?" We talk about temperature an awful lot considering that we don't really know much about it beyond using it to express the feeling that something or someone is hot or cold. So what exactly is temperature? Temperature is a number or quantity assigned to indicate how warm or cold something is. We're basically measuring the energy being transferred from one thing, like the air, to another, like a thermometer. A thermometer can give us a fairly accurate reading of temperature from a state of thermal equilibrium with the object it is measuring. There are 3 common scales for measuring temperature: Celsius, Fahrenheit, and Kelvin, and a reading of 100 on any of the 3 will mean something dramatically different. On the Fahrenheit scale, an outdoor temperature of 100 degrees would indicate an average summer day in Southern California. Created near the turn of the 18th century, the Fahrenheit scale is named for its German creator, D.G. Fahrenheit. This scale proposes that water freezes at 32 degrees and boils at 212 degrees. On the Celsius scale, an outdoor temperature of 100 degrees would indicate that climate change has turned us all into spaghetti noodles in need of boiling. The Celsius scale is named for a Swedish astronomer from the 1700s named Anders Celsius. He proposed a scale that starts at the freezing point of water, 0 degrees, and ends at the boiling point of water, 100 degrees. This system is absolutely more straightforward than Fahrenheit's. An outdoor temperature of 100 kelvins, the equivalent of negative 279 degrees Fahrenheit, would indicate that the Earth has frozen solid. Lord Kelvin introduced this scale for measuring temperature in 1848. He felt that the scientific world needed a temperature scale with a null point at absolute zero. Thus, the Kelvin scale was born. This system is unique in that, unlike the Celsius and Fahrenheit systems, there's no such thing as a negative Kelvin. What the Fahrenheit? According to the World Atlas, fewer than 3% of the countries in the world use Fahrenheit as their standard temperature scale. The United States is one of them. The rest of them are so small you'd barely be able to see them on a world map. Perhaps this was once intended to make us seem cutting edge, but really all it does is add more brush strokes to the painting of the United States as a petulant toddler. Once the United States joins the ranks of the rest of the planet, the Fahrenheit scale will likely become obsolete. That's all we have to say about heat today. Thank you.